Hello everybody. In this video tutorial I want to show you how we can find and handle an outlier in a dataset, and we are using, in this particular case, we are using the IQR, the Interquartile Range method for this purpose. So what we just as a reminder what we are talking about, let's say we've got a data set here and it is already ordered in ascending order. We can calculate a median of this data set, and this median splits the data set basically into 50% lower range and a 50% upper range. That's this part here. So that's this one here, and a 50% lower range. And we can split the lower and the upper range that we got again into submedians, if you like. And they are called quartile 1 or quartile 3 respectively. The true median of the whole data set is a quartile 2. We can represent that with a box plot. So here, quartile 1, that's the lower median, that's this part here. Quartile 2 is the median of the data set, and quartile 3 is this part here that we have. And then, of course, we've got the whiskers here to the left and to the right that indicate the minima and the maxima. And we also can say that we can calculate the interquartile range. That's also a range that contains 50% of the data. That's this one here. If we just simply do quartile 3 and minus quartile 1 that we have here. So quartile 3 minus quartile 1, that gives us the interquartile range. And it is sort of common practice to say an outlier is a data point, that is either larger than Q3 plus 1.5 times the IQR, or smaller than Q1 minus 1.5 times IQR. So, for example, we could determine a sort of a fence with this information, and this is called the two-key fence. The two-key fence for our data that includes exactly this upper outlier and the lower outlier. Which is defined by these two data points. So let's have a look at a simple data set. 1, 2, 3, 4, 5, 6, 7. So that's our very basic data set. And we can calculate the median, so that would be our Q2. And now we can also calculate the median of the lower half and the median of the upper half. And in a previous video I showed you how we can use two different methods, the inclusion and the exclusion method. Let's use the exclusion method. The exclusion method will not use the Q2 for the calculation, so it will just use 1, 2, 3 and then 5, 6, 7, and for Q1 we would get as the lower median we get 2, and for the Q3 we get the upper median, so that's 6, and we can calculate the IQR for that. which is 6 minus 2. And that gives us, of course, 4. So that's the interquartile range. And we can now say, okay, in order to calculate the upper fence of the two key fence, we use Q3 plus 1.5 times IQR. So Q3 was 6 plus 1.5 times 4, that's also 6, would be 12. And for the lower fence, we would calculate Q1 minus 1.5 times IQR. And here we've got 2 minus 6. So this would be negative 4. So any data points that are smaller than negative 4 or larger than 12 would be considered outliers. So that is the IQR method. Now, what are we going to do with outliers? Now, we have different options when we are dealing with outliers. So how to handle outliers? Let's say we've got the data set 1, 2, 3, 4, 5, 6, 18. So in this data set, we very clearly see that we've got an outlier here, and that would be because it is larger than the upper fence. So we would have basically our box plot would look like this. So we've got 2, we've got 6. So our box plot looks like this. What we would do is we draw a whisker to the lower one that is not an outlier, but we would not draw a whisker to the outlier here. We would just simply indicate that with a label or something like that and say that there's an outlier. So what are we going to do with that? Well, there are different options, as I said. One option would be just to ignore the data, ignore the outlier, and just simply say we include it. Calculations or whatever we do with it. Now, this has the disadvantage that the outlier will affect the mean, and, for example, standard deviation, and basically everything that we are doing with it. The second method that we could use is disregard the outlier. And that we just simply say, we just do not include outlier. And we do all the calculations based on the data without the outlier. Problematic if we've got a very small data set. Problematic for small data sets because, every little helps, as they say, and we need all the data for small data sets. A third method, which is very commonly used, is called Winsorizing, named after an engineer and a biostatistician. And in Winsorizing, it is we replace the outlier, with the closest non-outlier. So if we did that, the closest non-outlier in our data set up here would be 6. So our new data set, the Winsorized data set, Winsorized data set, and with which we can do mean, median, and so on calculations. It's a very common technique, but we need to very clearly state in our method section or whatever where we describe what we've done, what we did, and that we are found an outlier which we Winsorized and eliminated. We might even want to give a justification for that, but we say it is a small data set and we wanted to maintain the number of data points, but we were aware that there was an outlier and therefore the data set was Winsorized. So I hope this makes sense, and thank you very much for watching.